Alright guys, welcome to our channel Code with Sunny, and in this video I will be talking about the problems of Codeforces educational round rated for Div2 115, round 115. Okay. So let's start with the problem A without wasting our time. So this problem basically involves you can say a simple, you have to check it out whether the sum of the cells are equal or not, we're consisting of ones. Like this problem involves the concept of not saying it as concept, but you need to require to implement something. Okay, so let me explain it with the help of this diagram. So we would be given some 2 into n matrix like that. Okay, so it would be like this one, 2 into n matrix, and you are at this position, and you need to go up to this position, right? And there are some of the cells that is being marked. Like if the cell is marked as 1, it means that it is blocked, something like that. Let me just confirm it out. Where it is, line 0 and 0 corresponds to the safe cell and 1 corresponds to trapped cell. Okay, so you can consider like that, if the cell consists of one character 1, then it is blocked, otherwise it is safe to move. And the possible moves are like this one. Like if you are at this current cell, you can go to the right one if it is like if the cell is not blocked, and you can also go to the left one, and you can also go to this downwards, and you can also go diagonally, and similarly to this one also. Like there are total how many types of moves? This one, two, three, four, five. Five types of moves that you can do if the cells are present. Like at most five types of the moves that you are going to do if the adjacent cells are what, safe cells. Okay. Now you need to check it out whether you can go from this position to this position or not. Okay. So like if you are at this cell, suppose that this cell is blocked. Okay, so it will consist of 1 and it will consist of 1, and your current position of the cell is like this position. Okay, I'm just finding it out the different possible cases. Okay, whether we can go to the destination cell or not. Okay, so suppose these two types of cells are blocked, like it is a diagonal pattern, then you can still go to this cell diagonally and you can reach to this destination cell. And what about the case when the cells are like this one, 1 and 1, and you are at this current cell position, this one, then you can still go to this cell, and still you can go to this cell, and you can reach up to this one also. Okay, so it means that whenever the blocked cells are placed diagonally, you can still go, like you can still cross these cells and move further. Okay, and what about the case when the cells are present like this one, like 1 and 1? It means that the blocked cells are exactly blocking the entire column, and we have 2 into n type of matrix, and you are at this position. Okay, so you cannot go to this one because it is blocked, and similarly you cannot go to this one because it is blocked. You can go to here and you can go to here, but you cannot because it is a blocked cell. So whenever the blocked cells are of this type, like 1 and 1, you cannot reach the destination cell. Okay, so it is like the problem is completed. You have to check it out whether the cells are being blocked or not, like in this pattern, like the entire column is going to be blocked or not. Okay, so let me just zoom it out. What we have done is, like, we have taken the input and entire input first, and then we are going to check it out if the particular column consists 1 and 1 at the 0th row and the very first row, then we are done with it. That is, our answer is going to be no, we cannot reach the destination cell. Otherwise we are obviously going to reach the destination cell, hence we are going to print yes. Okay, so let's move on to the second problem. So this problem is like very much easy. This problem involves the brute force kind of technique, and you need to just check it out. The some of the condition, mathematical conditions. Okay, so let's move on to understand this problem. Like we would be having n students, and we need to divide these students into two groups, like group G1 and group G2, and these two groups must be of same size. Let's call it as X. Okay, and like all of these students is going to work on some particular day, and the day are going to be defined from 0 to 4, both inclusive. And like some students is going to be convenient to work on a particular day, and some students is not going to be convenient to work on that day. Like if the particular student is convenient, it is going to be denoted by, let's call it as matrix of like ith student, and it is going to be convenient at jth day or not is going to be denoted by the character 1. if it is convenient. Otherwise it is going to be denoted by the character 0 if it is not convenient to work on the jth day for the ith student. Okay, and also we need to divide these students into two groups, g1 and g2, and both group g1 and group g2 is going to work on the two different days. Like if g1 is going to work on the ith day, sorry, if G1 is going to work on the, let's say, day number 0, and then G2 must be working on some other day, like other than 0. Okay, and all those students which are going to lie in the respective groups must be convenient to work on that particular day. If it is possible, we are going to print yes. Otherwise, we are going to print no as our answer. Okay, so how we are going to do that? So let's try to understand this one. Like you can see that J is going to vary from 0 to 4, right? And as I have already said, if the group 1 is going to work on the J1 day and group 2 is going to work on the J2 day, then J1 and J2 must be distinct. So what we are going to do is we are going to iterate for every j1 belongs to 0 to 4, and every j2 belongs to 0 to 4. We are going to check out every possible pairs. You can see that these count are not very much. It must be around like 5 into 5 25. Sorry, 5 into 5, yes, 25. And we must take care that j1 must not be equal to j2. And how we are going to approach the answers? Okay, so what we are going to do is let's say at a particular j1, and we have a particular j2. Okay, and what we are going to do is we are going to iterate for all those n students. Okay, we need to calculate for a fixed j1 and for a fixed j2 right now. Okay, and we are going to iterate for n students, and we will find out the count of what, count of the number of students which are convenient to work on the j1th day, and similarly which are number of students which are convenient to work on the j2th day. Okay, so let c1 denotes the number of students which are convenient to work on the j1 day, exactly like students convenient to work on the j1th day only and only on j1th day, not on j2th day. Okay, and similarly we will try to find out c2, number of students which are convenient to work on only on this day. Okay, and there will be a common variable called both will be just like finding it out the number of students which are convenient to work on this day and this day also, like both of the days. Okay, so how we are going to do that, like how we are going to just say that our answer is going to be possible, right? So now the problem boils down to a very simple concept. We need to divide the students into two groups, right? G1 and G2 having equal size, right? So suppose that let me just take some example, and it will make us very much clear. Okay, so one thing also you need to ensure that C1 plus C2 plus the both all these frequencies must match with n. Like all the students have either convenient on the either of the days also. You need to check it out also. Like this condition must hold. Okay, so like suppose you have this 3 and you have this 5. C1 is going to denote 3 and C2 is going to denote 5. Like 3 students are going convenient to work on the J1 day, and 5 students are convenient to work on the J2 day, and both is pointing it out as 2. Okay, so what you are going to do is like you are going to check it out that first of all this 3 must match with this 5. Okay, so let us take both as 4 to understand this problem easier. So 3 must be equal to 5. So what you are going to do, since both denotes the number of students which are convenient to work on the both of the days, so you will just put out you will just extract two amount of students and you will just put it out over here. So it will become 5 and 5. Now this 4 becomes 2. It means that the remaining number of students which can be convenient to work on this J1 day and J2 day is 2. So you will just divide it equally. So it would become 6 and 6. And you can see these two counts are same. So you will say that yes, we can have the two groups where the every student's desires are satisfied. So the code is like very much simple. You need to just implement the things that I have mentioned over here. What we are going to do is like first you have taken the input of size n into 5 in a matrix, which is going to denote the ith student is going to be convenient to work on the jth day or not. Okay, and we will just take it out every pair, like I from 0 to 5, j from 0 to 5, and just find it out this count 1, count 2, and both. It is going to denote the, like count 1 is going to denote the number of students which are convenient to work on the ith day, and count 2 is going to denote number of students which are convenient to work on the jth day, and both is going to denote the like common students, like which are going to be convenient to work on the both of the days. Okay, and we will just iterate for all those students and fill out the, like increment the counts of both count 1 and count 2. And we will just ensure that these frequencies match, and we will be like making count 1 and count 2 exactly equal with the help of this both variable. Both variable is also may also hold some frequency. So what I've done is like we have ensured that count 1 will contain the smaller value, and if it is greater, I'm going to swap them, and if both is going to be like greater than count 2 minus count 1, we will just make it equal by making what, by subtracting both by an amount equal to count 2 minus count 1, and after doing that, if both is even, we can divide it equally, and if it is possible, print yes. Otherwise, after all these operations are done, we are going to say that there doesn't exist a valid division into two groups. Then we are going to print no as our answer. Okay, so this is for the problem B. So let's discuss the another problem, problem C. Okay. So like this problem is also categorized into some simple concepts, like you need to know the tricks of hash map, and you must be familiar with like hashing type of things also. Not the hashing, like you can use a like C++ HTL function like map or unordered map type of thing. Then you can solve this problem easily with the help of these things, these functions. Like, okay, so let me just elaborate these problem statement in a simpler way. So what we have been, like we have been given n integers, and integers is like, yes, it is being denoted by ARR, and we are going to say the mean. We are going to find out the mean of these integers. Mean of these integers is like sum s divided by number of integers. Okay, and what we are going to do is like I think delete exactly two elements. So we would be deleting the any two elements. So let's call it as s minus x plus y. So the new sum is like s minus x plus y, and the number of elements becomes n minus 2. And it is being said that this after deleting these two elements, the mean must match with the previous mean, like s by n. Okay, now you can see that there is a mathematical relation. You can solve it, and let us solve it out first. Like ns minus nx minus ny must be equal to ns minus 2s. You can see that ns and ns are cancelled, and if you just rearrange this, it would become nx plus ny must be matching with 2s. Okay, now the problem boils down to finding out any two integers in our modified array. Why I'm saying modified array? Because I am going to do this operation, array of I exactly equal to array of I into n. Why I'm going to do this one, array of I into n? Because you can see that I have chosen two elements x and y, but here we want nx and ny, right? So I'm going to modify my original array and make it array of I into n. Now this is my modified array, and let's say this is a plus b, and which must be equal to 2s. Okay, so we need to find out two elements in our modified array such that their sum must be matching with this value. Let's call it as 2s as y. Okay, we need to find it out two values a plus such that a plus b must be equal to y. So you can see that this is a very standard problem. You need to use a hash map to keep track of the elements that are present. Okay, so let me just elaborate in a simple way if you are haven't familiar with this one. Like you are at index 0, 1, 2, 3. Suppose that you are at this index, and this value is like, let's call it as array of I, and you need to find out two integers a plus b must be matching with some y, and you have the current value as array of I. Let's call it as this one, a. So in the hash map you will be just finding it out, mp of, let us say that mp is the hash map, mp of y minus my current element is a, which is array of I, and you need to increment your count by this amount mp of y minus a, because this will be denoting the number of elements satisfying this condition, because we have already subtracted y minus a, so the remaining element is the b only. Okay, and each time also after doing this you need to increment the current element frequency, which is mp of a plus plus. So this will just find it out total number of valid pairs I comma j, such that I should be going to less than j and a plus b must be exactly equal to y. This will give you the answer. Okay, so this is also very simple. We need to just implement the use the formula and use the hash map type of thing to solve this problem. Okay, so I don't know why it is not opening. Like the server is not good. Of Codeforces. Yeah, it has been done. Okay, so what I've done is like taken the array and just multiplied the array of I into n and taken the sum also, and I've multiplied sum by 2 also, because we need to work upon 2s, and taken the map answer as 0 and iterate through the entire array. Then our answer is going to be incremented by sum minus array of I. Note that this is array of I is the modified one, because we have done already this one, and I've incremented its count, and this will give you total valid pairs I comma j. Okay, and this will give you all test cases passed also. So okay, so let's move on to the next question. Okay, so this is the problem D, and we are going to discuss it. Like there is a person monocarp and it has n problems, and every problem has a particular integer associated with it, ai, which is going to vary from 1 to n, and a difficulty bi, which is also going to vary from 1 to n, and all problems are different, which is there is a pair ai comma bi which is going to be distinct. Okay, so if you're not going to understand this one, we'll be having some ai and we'll be having some bi, like this one. Okay, so where it is an integer from 1 to n, and it is going to denote the topic number, and bi is going to denote the difficulty. Okay, okay, so why I'm going to open this one. So this is for AI, and this is for BI. Suppose that AI is 2, it is means that the topic number is 2 and the difficulty it is 3. Okay, so like the pair is not going to be same. Like this pair 2 comma 3 has already occurred, so there doesn't exist any other pair denoting 2 and 3. Like this is not possible. Like you can have this 2 and you can have this 4, like topic number 2 and the difficulty is 4, you can have this pair also, but you cannot have 2 and 3. So this is what it means. All the problems are different, that is that there are no two tasks that have the same topic and the difficulty at the same time. Okay, and like we would be choosing any three problems, like any three tasks from all these n tasks from the problem set. Okay, such that it is going to satisfy at least one of these two conditions, like it is going to satisfy this condition, or it is going to satisfy this condition, or both of them. Like all the topics, total number of ways we have to find, total number of ways to choose any three problems from the n problems, which is going to satisfy at least one of these constraints. Like the constraints are the chosen problems have the topics, all the different topics it should have, or the difficulties of all these three problems should be distinct, or the both of the condition can also be satisfied. We need to take care for that. Okay, now like we need to find out the total number of ways, in the problems like this one, like in the problems involving total number of ways, you have to find the combinatorics related type of problem, and you will be given some condition, like at least one of these conditions or at least two of these conditions must be satisfied. Then most of the problems is going to be easily solved by total number of ways minus the condition that should be avoided. Okay, if you are going to do that, then the problem can be easily solved. Like in most of the problems we are going to approach by this way, and problems involving the at least criteria. So here also we are going to do the same thing. Okay, so let me just first erase it out. We need to choose three problems. So what is the total number of ways? Let's try to find it out first. Total number of ways, there are n problems. We are going to choose any three distinct problems. So it should be like n into n minus 1 into n minus 2 upon 6. So this is the total number of problems. Okay, and we need to avoid that condition. Like our answer is going to be let T is the total number of ways to choose three problems minus the wrong set. Let's say wrong set means we are going to choose three set of problems like S1, S2 and S3 which should not be included in our answer. So how we are going to subtract these cases? Okay, now let's first work upon wrong cases, because if we are able to find it out, then we are done. Okay, it means that we need to avoid those triplets of problems which are going to be which are going to be not satisfying this criteria. We need to subtract it out. So what if you write down the criteria in a simpler manner? You are going to be initially we would be having at least one of these two conditions possible. Then if you just work in a reverse manner, you'd be total minus all the topics, here also all the topics of the three selected problems is going to be different. Then you are going to have the, let's say, topics is going to be denoted by T and the difficulty is going to be denoted by D. Then you would be subtracting it out like all T same, we are going to choose three problems, right? And three difficulties being same. Okay, you need to work upon the original problem is the topic should be distinct and difficulties should be distinct, and there is at least criteria over here, and we are going to use and criteria over here because we are going to work in a reverse manner. Like the three topics should be same value and three difficulties should be of same value. Like they are in the pairs, right? And if this is going to be the one of the criteria, then what are the more criterias? Like three topics same and two difficulties same. Okay, and similarly two topics same and three difficulties same. Okay, and again we would be having two topics same and three difficulties same. Okay, note that we are working upon the wrong cases, right? Why I'm saying it out, like let's say we are going to work upon this three topic themes, like we would be having two and two difficulties same, so we'd be saying like three and let's say 7. So this is one of the case we need to avoid this case, because the this criteria is not going to be fulfilled. You can see the topics of the three selected problems are different, but here it is same, and the difficulties of all the three selected problems are going to be different, but here it is not. So this number of these type of problems should be subtracted from our answer. Okay, so we would be working upon that. Now the more tricky part is like some of the cases are already being discarded. Like you need not to work upon this case, you need not to work upon this case, you need not to work upon this case, and you need to work upon this case. Why? So let's try to understand this with the help of small example. Three topics same and three difficulties same, so you would be having like two, three and 3. Okay, now here is a contradiction that arises. And what is the contradiction? You can see that this pair is same as this pair, right? And the problem statement says that there are no two tasks that have the same topic and difficulty. So here there is a contradiction. We cannot have this case being taken. And here also three difficulties same. So let's say three, and sorry, two difficulties same, right? So let us take let's say five. Now here it is three topics here. You can see that again there is a two pairs having the same type of values. So this is also discarded. Similarly, this one, but this is not this is taken. I think I've written the wrong thing over here. Yeah, now it is correct. Let me just take it. Two topics same and two difficulties same. Yes, this is correct now. Okay, so we would be having this one as let us take an example like two, and let's say 3, and we would be having two difficulties same. So we can say that it should be like 2, and let's say we would be again having 2, and let's say we would be having let's say a different one. You can say that it is of 3. Now this is not possible. So what you are going to do is like you would be making any two difficulty same in a different manner. Like if you put a 2 over here, then you are going to put a 2 over this position. And what is the number that should be present over this position? The number that is present over this position is different than 2, let's say 4. Now you can say this is a valid criteria. This should be included in the wrong cases, and these type of problems should be subtracted. You can see that there are two topics being same and two difficulties being same, and there are no two problems having the same pairs. You can see this is 2 comma 2 distinct, 2 comma 4 distinct, 3 comma 2 distinct. Okay, so this is the valid one which should be included in wrong cases, and this should be subtracted. But how we are going to find out such type of pairs? Okay, so what we are going to do, we will be having the AI and we would be having BI. Okay, so first of all, what we are going to do is I'm going to just mention it out, then I'm going to say why we are going to do this. First of all, we would map every AI like with BI, and it should be like in the adjacency list manner. Why we are going to do this? Like suppose so we would be having 2 3, 2 4, 2 5, and let's say we would be having okay 3 5 and 3 4. Okay, so we would be like these are the values of A and these are the values of B. We would be mapping in adjacency list type of format. Note that this is the mapping I'm talking about is like AI to BI. Okay, so you can see that 2 is going to be mapped with 3 as well as 4 as well as 5. So 4 and 5, and similarly 3 is going to be mapped with 4 and 5. This is for AI to BI, and similarly we are going to map for BI to AI. It should be like 3 should be mapped with 4 and 4 should be mapped with 2, and like where it is, yes, 3 should be mapped with 2, 4 should be mapped with 2. I think this is not possible. 4 should be mapped with 2. uh, yes, wait a minute, like 3 should be mapped with I think I've written something wrong. 3 should be mapped with okay, so let me just 3 should be mapped with 2, 4 should be mapped with 2, and 4 should be mapped with 3, you can see, and 5 should also be mapped with 2 and 3. Okay, now these are the possible mappings, and like we are doing in the adjacency list type of format. Now how we are going to approach the answers? Like you need to work upon two topics same and two difficulties being same. Okay, now let's say that we are working upon the current list, like we are working upon this type of format. Okay, we are going to choose two topics being same. It means that if we are going to choose the pair 2 and 3 and 2 and 4, like this pair, if we are going to choose this pair, you can see that it should be like 2 3 and 2 4. Okay, if we are going to choose this pair, these two pairs, now the third pair is still unknown, but we have we have approached the one of the criteria, which is two topic being same. And how we are going to be like how we have approached this criteria, the it is like very much simple. You are going to iterate in that adjacency list having the same value. Okay, so the value is 2 and we are going to iterate in 2's adjacency list. Okay, and 2's list is containing 3 4 5. It means that the mapping from AI to BI contains 2 3 2 4 2 5 similarly. So I have taken any two elements from this one, so it should be like 2 3 and 2 4. Okay, now the third element is still unknown. Okay, and now the third element has the BI, like this is the position of BI, right? And it has the BI. It can be anything. It can be like anything means from either 3, from 4, like either from 3 or 4, because we need to satisfy this condition also. Okay, so we are going to say, let's say it is 3. Okay, so how the number of triplets that we need to include into our answer? Okay, how we are going to do that? So the it is totally being dependent upon how we are going to choose this number. Okay, so how we are going to do that? So what we are going to do is we are going to iterate in 2's adjacency list, and let's say we are going to choose 3. Okay, so if I'm going to choose 3, okay, so it means that I'm going to just say that I'm fixing this criteria of two difficulties being same, and the difficulty value is going to be 3. So I will just pick up another number 3. Now what are the number of ways to choose this another number as 3 being bi? So we need to iterate in the b's adjacency list, like b of 3. Okay, note that this is mapping from bi to ai. We need to find out this size, and there are size minus 1 number of ways to choose this value as 3. Why there are size minus 1 number of ways? Why not size? Because we have already chosen 3 to 2 mapping. Okay, we need to choose another mapping rather than 3 to 2, which is having the value as bi equal to 3. Okay, so there are size minus 1 ways to do that. Okay, but there are one more condition. And what is that condition? Still this number is unknown. What is this middle number? Now this condition is satisfied. There are size minus 1 ways to choose this bi if we choose this as 3. Okay, but you need to we ensured that the two topics must be same. So if you choose 3 as the current value right now, you can say that this is the 3. So the next value, that is the second pair that is being chosen, there are, what is the size? Let's say the size is x, then x minus 1 ways to choose the pair at this position. Like the if you choose a 5, then it should be like 2 and 5. If you choose out the 4, you will having 2 and 4. You can't choose 2 and 3 because it will violate the criteria. Okay, so there are x minus 1 ways. You can see the size of list is 3, and you can choose 2 4, and you can choose 2 5. So it is like 3 minus 1 2 ways, and multiplied by what is the number of ways to choose this one, this position. It is totally dependent on adjacency list of B to AI, and you need to find out the size of B of 3, and you should be subtract minus 1. Why we are going to subtract minus 1? Because this pair has already been taken 3 to 2. So there are you need to choose another pairs from BI to AI. So there are size minus 1 pairs. So you would be multiplying the first value x minus 1 into size minus 1, s minus 1, let's say s minus 1, where x is the size of this one, and similarly this s is the size of b of 3 right now. If you take this as 3, if you take this as 4, then b of 4 minus 1, if you take 5, b of 5 minus 1, and so on. So this will give you I think the correct answers. Like you not saying it right now, let's say our answer is total value minus the wrong cases. Okay, so total is NC3 minus wrong cases is let's say answer is CURR current, which is going to be like sum of all those values x minus 1 into s minus 1 for all those positions like 3, 4, 5, 4, 5, and this and so on, whatever the mappings from AI to BI you can have. You are going to do this product and find out this valuable current. So your answer is NC3 minus current. So if you are not understanding this right now, let's head over to the code to understand this in a simpler way. Okay, so what I've done is finded the adjacency list of A to B and similarly B to A. First I've taken the input, and first I've put out all the elements in the adjacency list and find out the total answers, and we are going to subtract the unwanted cases also. Okay, so how the cases is going to, as I've already said, two same A and two same B, like two same topics and two same difficulties, and we are going to work for every element. First we are going to go on for the mapping from A to B, and we are going to say that if I'm going to choose a current element U. Okay, so we have Sj minus 1, which is for the the current size of the elements. You can see, if you are not getting it, this is x minus 1, where x is over here is Sj. You can see that the size of this adjacency list minus 1, because if you choose 3, there are like size of adjacency list minus 1 x minus 1 ways to choose another pair. And similarly, you need to be ensured that the two difficulties are also same. So what is the number of ways to choose another pair? It should be like same count. Same count is b size minus 1. Like adjacency list of b of u dot size minus 1 means the mapping of mapping in the adjacency list of b and the element is like 3. Okay, if you are not going to get it is like 3. 3 is mapping to 2. What is the size of this list? If you are at 4, what is the size of this list? Okay, and your answer is going to be decremented by this amount every time. Finally print this answer. We are going to get all the test cases passed. So if you have any doubts, do let me know in the comment section of the video. And I will ask the viewers to like this video, share this video, and do subscribe to our YouTube channel for latest updates. Thank you for watching this video.